Welcome to Spring LIB.
We need to find the displacement of the boat after Juliet moves to Romeo. So let's draw the system. So let's imagine that we have a boat on the water, and the shore is located somewhere here. Juliet is closer to the shore because she's moving away. And Romeo is on the other side of the boat. So obviously, if Juliet moves to the left, the boat will be moving to the right. So this is like our intuition, but now we are going to prove it. So let's first assign the x-axis, and as this x-axis we will first label the shore. So initially Juliet is here and Romeo is here, and the distance between Juliet and Romeo is L, which is the length of the boat. Let us assume that U of Juliet is Juliet's speed versus boat. Meanwhile, V Juliet is Juliet's speed versus water. And in our case, water doesn't move. So it's our stationary system. Let us presume that the U Juliet is directed in the opposite direction to the x-axis, so is V Juliet. But the speed of the boat, V boat, is the speed of the boat with Romeo. It's directed to the positive direction, so here. Now let's recalculate the speed of Juliet versus lake. Speed of Juliet versus water equals to the speed of Juliet versus the boat plus speed of the boat versus water. When it's projected on x-axis, negative V Juliet equals to negative U Juliet plus V boat, because only boat moves to the positive direction of the x-axis. And from here we can express V Juliet, it equals to U Juliet minus V boat. This is our first equation which we're going to use to solve the problem. Secondly, we need to realize the conservation of the momentum. The initial momentum is zero because everything is still, but then Juliet starts to move, and when projected onto the water, onto the stationary system, mass of Juliet multiplied by her speed versus water plus mass of the boat and mass of Romeo multiplied by speed of the boat. So if we take into account signs with respect to the x-axis, mass of Juliet multiplied by the speed of Juliet versus water numerically equals to the mass of boat plus mass of Romeo multiplied by the speed of the boat versus water. So now let's use equation 1. Mass of Juliet multiplied by speed of Juliet versus the boat, negative mass of Juliet multiplied by speed of the boat versus water equals to the sum of mass of the boat and Romeo multiplied by the speed of the boat versus water. From here we need to express mass of speed of the boat. So speed of the boat equals to speed of the boat multiplied by mass of the boat plus mass of Romeo plus mass of Juliet equals to mass of Juliet multiplied by speed of Juliet versus the boat. As we know, speed of Juliet versus the boat can be found as length of the boat divided by the time which was needed for Juliet to walk Romeo. And as we know, this time is also required for the boat to move. That's why delta x, the displacement of the boat, equals to speed of the boat multiplied by delta t, or speed of the boat equals to delta x, displacement of the boat, divided by the time of the displacement. So now we can put this expression to the previous equation, and from here we're getting that mass of Juliet multiplied by length of the boat divided by delta t multiplied equals to delta x divided by delta t multiplied by the total mass of Romeo, Juliet, and boat. So delta t cancel each other, and that is why delta x, the displacement of the boat, equals to mass of Juliet divided by the total mass of the system. And multiplied by the length of the boat. In our case, it is 55.0 kilograms divided by 55.0 kilograms plus 77.0 kilograms plus 80 kilograms, all multiplied by 2.70 meters, which is equals to 0.70 meter. So the answer is delta x, displacement of the boat, is 0.70 meters.